Okay, I've got quite a few word problems here I'm going to show you, so I may have to speed through some of them. Okay, let's start with the number problems. Okay, these are just problems that involve numbers. A number plus itself plus twice itself plus 4 times itself is equal to 104. What is the number? Well, this is pretty straightforward. Just let n represent the number, and then take the number plus itself plus twice itself, then plus 4 times itself, equal 104. And then if you add that up, n plus 2n plus 4n, that's 8n, and 8n equals 104. So now divide both sides by 8, and you get n equals 104 divided by 8, which is 13. So the number is 13. The next one says 14 less than 8 times a number is, so that would be an equal to, 2 more than 4 times the number. So let's let n represent the number, and so 14 less than 8 times the number, that would be 8n minus 14, and then 2 more than 4 times the number would be 4 times the number plus 2, and remember these two are equal. So now we can solve this. Here, if we add 14 to both sides, that'll eliminate the minus 14 here, and it'll give me 4n plus 16 over here. Then I can subtract 4n from both sides, and that'll eliminate the 4n that's over here, and then that'll just leave me 16 over here, and then 8n minus 4n is 4n. And now divide both sides by 4, and you get n equals 4. So the number must be 4. The next one says the sum of 3 consecutive integers is 108. What are the integers? Well, consecutive integers are integers that differ by 1, like 3, 4, and 5, or 7, 8, and 9. So let's let x be the smallest one, x plus 1 be the middle integer, and x plus 2 be the largest integer. Now, since they add up, it says the sum of these add up to 108, just add them up, x plus 1 plus x plus 2, and set it equal to 108. Well, if you add these up, you get 3x plus 3 on the left equals 108 on the right. Then if you subtract 3 from both sides, you'll get 3x equals 105. And then if you divide both sides by 3, you get x equals 105 divided by 3, which is 35. And so the smallest integer is 35. The middle integer is 35 plus 1, which is 36. And the largest integer is 35 plus 2, which is 37. All right, next I'll do a couple of geometry problems. It says the second angle of a triangle is the same size as the first angle, and the third angle is 12 degrees larger than the first angle. How large are the angles? Well, on this one, we know that x is the size of the first angle, and then we can let x be the size of the first angle, and the second angle is the same size, so x would be the size of the second angle, but the third angle is 12 more than x, so x plus 12 would be the size of the third angle. And since we know when we add all 3 angles in a triangle, they add up to 180 degrees, then we can take the first angle plus the second angle plus the third angle, and we get that equals 180. And then if you add those up, you get 3x plus 12 equals 180. Now subtract 12 from both sides, and you get 3x equals 168. Then divide both sides by 3, and you get x equals 56. So the first angle is 56, and the second angle is the same size as the first, so it's 56. And the third angle is 12 more than the first angle, so it's 56 plus 12, which is 68 degrees. The next one says the perimeter of a rectangle is 150 centimeters, and the length is 15 centimeters greater than the width. Find the dimensions. So I'm going to let W be the width. Then since the length is 15 centimeters more, then the length is going to be W plus 15. Now the formula for the perimeter of a rectangle is you take twice the width plus twice the length. And so the left-hand side is the formula for the perimeter, and we're given that the perimeter is 150. So the left-hand side should equal 150. So now distribute the 2 here, and you get 2w plus 30. So the left-hand side is 2w plus 2w plus 30. And then combine the w's, and you get 4w plus 30. Then you can subtract 30 from both sides, and that'll give you 4w equals 120. and then divide both sides by 4, and 120 over 4 gives me 30. So the width is 30 centimeters, and since the length is 15 more than the width, then the length must be 45 centimeters, 30 plus 15. Okay, the next couple of problems involve ages. It says here a father is 4 times as old as his son. In 20 years, the father will be twice as old as his son. Find the present age of each. So we need today's age. So I'm going to let X be the son's age, and since it says the father is 4 times the son's age now, then 4X is going to be the father's age. So X is the son's age now, and 4X is the father's age now. So in 20 years, we would add 20 to get the son's age in 20 years. So the son's age in 20 years is X plus 20, and the son's age in the father's age in 20 years would then be 4X plus 20. Now, it tells us that in 20 years, the father's age will be twice the son's age. So since this is the father's age in 20 years, that's got to equal 2 times the son's age in 20 years. So if we get 4X plus 20 equal 2 times the quantity X plus 20. Now, if I distribute the 2 here, I get 2 times X plus 2 times 20, so I get 4X plus 20 equals 2X plus 40. And now you can subtract 20 from both sides to get rid of this 20. And over here you'll have 2X plus 20 when you subtract the 20. And on the left you'll have 4X. So we have 4X equals 2X plus 20. Now to get the 2X away from the right side, subtract 2X from both sides. And then that way the 2X will cancel over here. And on the left you'll have 4X minus 2X. So 4X minus 2X is 2X. And then all we have left on the right is the 20. So since 2X equals 20, you can divide both sides by 2 and get X equals 10. So the son's age is 10 years, that's present day, and the father's age today is 40 years. So that's the present age of each. And by the way, if you bump these up 20 years, the son would be 30, the father would be 60, and so you can see it matches what it says, that the father would be twice as old as the son in 20 years. Okay, this one is Fred and Barney from the Flintstones, I guess. Fred is 4 years older than Barney. 5 years ago, the sum of their ages was 48. How old are they now? Well, let's let X be Barney's age today. And since Fred is 4 more than Barney, we'll let X plus 4 be Fred's age today. Now, we need to back up 5 years ago. Let's find out what their ages were 5 years ago. Well, I don't know their actual ages, but I know Barney's age today is X, so 5 years ago his age would be X minus 5. And today Fred's age is X plus 4, so 5 years ago his age would have been X plus 4 minus 5. Well, X plus 4 minus 5 is actually X minus 1. So I can use X minus 1 for Fred's age 5 years ago and X minus 5 for Barney's age 5 years ago. And if I add those two ages together, that should equal 48 because it says those ages 5 years ago added up is 48. And then so if you add these together, you get 2X minus 6 equals 48. And then you just subtract 6 from both sides. You add 6 to both sides, and you get 2X equals 54. Then if you divide both sides by 2, you get X equal 27 for Barney's age, and X plus 4 equals 31 for Fred's age. Okay, the next problems are distance, rate, time problems. If I'm going too fast, feel free to pause the video and look at these. Okay, so the distance is rate times time, and time would be distance divided by rate. It says here a man walks at a rate of 4 miles per hour. How far can he walk into the country and ride back on a trolley that travels at a rate of 20 miles per hour if he must be back home 3 hours from the time he started? So we know the total time has to be 3 hours. Okay, so let's let D be the distance he walks into the country. And by the way, that's also the distance he travels when he travels back. So since D is the distance, when he walks into the country, he's walking at 4 miles per hour. So the time, remember, is distance over rate. So the time it takes him to walk to the country must be the distance he traveled to the country divided by the rate, which is 4. And then the time for him to come back must be the distance he traveled back, which would be the same as the distance going, divided by 20, which is the rate of the trolley. So now we know that the distance d over 4 is the time walking into the country, d over 20 is the time returning, and that's got to be equal to 3 hours. Now, to solve this, get the lowest common denominator, which is 20, and just multiply each term by 20 to get rid of your fractions. And if I multiply this by 20, I get 5d. If you multiply d over 20 by 20, you get d. And multiply 3 by 20, you get 60. And then if you add the d's together, you get 6d equals 60, and then divide by 6, and d equals 10 miles is the distance that he can travel. So 10 miles is the distance that we're looking for. Okay, the next one is 2 campers left their campsite by canoe and paddled downstream at an average rate of 12 miles per hour. They turned around and paddled back upstream at an average rate of 4 miles per hour. The total trip took 1 hour. After how much time did the campers turn around downstream? So in other words, how long did it take them to go downstream? So let's let t hours represent their time traveling downstream. And since the total trip is 1 hour, the time traveling upstream would be the 1 hour minus the time it took them to travel downstream. So that'd be 1 minus t. Now I set a table up here for downstream and upstream trips. Downstream, they travel 12 miles per hour for t hours. So the distance is rate times time. So the distance they traveled downstream would be 12 times t. Now upstream, they traveled at a rate of 4 miles per hour, and the time was 1 hour minus t. And so if you multiply those together, you'll get the distance they traveled upstream, which is 4 times 1 minus t. But 4 times 1 minus t is the same as 4 minus 4t. Now, since the distance downstream and the distance upstream are the same, then the 12t and the 4 minus 4t must be equal. And so I can just solve those for t to find the time. So I'm going to add 4t to both sides to cancel the minus 4t, and then I get 16t equals 4, and then divide both sides by 16, and then you get 4 over 16, but reduced, that would be 1/4. So the time is 1/4 of an hour. So the time traveling downstream was 1/4 of an hour. Okay, let me finish these 2 problems as quick as I can here. A horse and a saddle cost $5,000. The horse cost 4 times as much as the saddle. What was the cost of each? Let C be the cost of the saddle, then 4C is the cost of the horse, and add those 2 up, and they got to equal the $5,000. So 4C plus C is 5,000, so that means 5C is 5,000. Divide both sides by 5, and so C is 1,000, and since the horse is 4 times that, the horse would be 4,000. And then the last one here, a 6-foot board is cut into 2 pieces. One is twice as long as the other. How long are the pieces? Well, let's let X be the longer piece, and then 6 minus X would be the shorter piece, because if you take a board that's 6 feet long and you take X away from it, you're left with 6 minus X. So we know that the longer piece, X, is equal to 2 times the shorter piece, 6 minus X. So that's our equation. And then 2 times 6 minus X is 12 minus 2X. So we get X equals 12 minus 2X. Now add 2X to both sides of this equation, and I get X plus 2X equals 12 minus 2X plus 2X. So I get 3X equals 12. And then if I divide both sides by 3, I get X equals 4. So 4 feet is the longer piece. And then since 6 minus X is the shorter piece, I know that X is 4, so 6 minus 4 would be 2 feet, and that would be the shorter piece. Whew. Wasn't sure I was going to get through all these in one video, but like I said, if I went too fast, you can certainly go back through the video again and pause it for places if I went too fast for you in some of these places. Alright, so that pretty much completes Chapter 1 of my Intermediate Algebra lecture.